talked a little bit about three different types of ways to write. The first one being that Cartesian, x plus iy. The second way was when we did the modulus argument form, and we kind of got comfortable creating a modulus and an argument. And then the last way is the exponential form, okay? So we're going to be doing multiplication or division, and we've done that already when it's in Cartesian form. So we're going to be kind of working with an exponential. Just want to kind of make sure we're cool with finding. So if I tell you u is equal to 5e to the 2i, exponential form, and w is equal to 10e to the negative 3i, okay? Can you find the, first, we're going to find u times w, and then we're going to find u divided by w, and then we're going to find the modulus and argument of each of them. Okay? So first of all, how do you think we are going to do u times w? When we had basic x plus iy form, the Cartesian form, we knew to FOIL, and then for division, we knew to use like the conjugate of that. However, this is actually pretty straightforward. If I'm looking at this guy and I'm multiplying by this guy, the numbers in the front multiply together, and then what do we do with exponents? When we multiply, we add our exponents. So really, this is going to be 5 times 10 e to the, and then we're going to add, so plus a negative 3i. So this particular one is going to be 50, and then e to the negative I. Are we okay with that? It's just basic multiplication of something with an exponent. And then how about the division aspect of it? So what would that look like? So we have 5e to the 2i, and we're going to divide by 10e to the negative 3i. I'll let you try that. Modulus argument, and then you have your exponential. And this is just multiplying with exponentials or dividing with exponentials. E to the 5i. All right. Are we okay with the multiplication of them? So far okay? Decent? Fair to middling? Okay. So let me give you two little formulas that you're going to have to know. If I'm taking two different complex numbers, okay, and let's say I'm going to tell you the first one, its measurement we're going to call R1. Okay, and then I'm going to give you a second one, and its measurement is called R2. Okay, and the arg for Z1, okay, we're going to call theta 1, and then the arg for Z2, we're going to call theta 2. All right. If I'm multiplying the two together and I'm trying to find their modulus of two things multiplied, okay, so let me give more room to this. That's going to be R1 times R2. But that can be broken up into the modulus of the first guy times the modulus of the second guy. And the same thing with arg. If I'm looking for the arg of the two multiplied together, okay, then it's going to be theta 1 plus theta 2. We add them together. So it's basically the arg of the one, and then plus the arg of the second one. And with division, so Z1 divide by Z2. Can you guess what the R would be in that case? I'll answer. Well, I haven't had a chance. I'm teaching right now. Yeah. All right, let me go. All right, sorry. My older son wants to bring his girlfriend's parents down to meet us. I'm like, oh, could be interesting. I didn't think I was there. Okay, I'm gonna give you all that.
This isn't given, is it?
It's what?
We should remember all of this.
Oh. It kind of comes naturally after a minute.
Oh,
I promise. It seems awful. Well, think of the R stuff, which is the modulus stuff. It simply gets multiplied or divided, depending on what the original situation is.
okay.
And then the arg stuff, when you're multiplying, you add. When you're dividing, you subtract. Okay?
Yeah.
Yeah? Okay. And let me put it into concrete example, so that would probably help us. So I'm gonna give you two different ones. So the first guy, U is equal to 9 plus 12i, and W is equal to -5 minus 3i. Okay, I want to find, eventually we're gonna do, that's a U times W. Okay, so if it's asking me to find the modulus and eventually the argument, okay. So it says, when I'm trying to find the modulus, do you guys agree that this little symbol indicates we're looking for modulus, the straight lines? Yeah, okay. So if I'm trying to find the modulus of two guys multiplied, we have options. We could do the whole thing together, or recognize that if I find the modulus of the first guy and I find the modulus of the second guy, I could just multiply them together. Okay, so that's what that's saying. So what would the modulus of U be? So let's find that first. So what is the modulus of U? It's a good review from yesterday. How do we find the modulus of U? Does anybody remember off the top of their head? Square root of 9 squared plus 12 squared. Okay, so calculate that out and give me what that guy is. You get 225, and that should be a good square root. What is that?
15.
Okay, cool, 15. Okay, so that's the first step. So now we're going to do the same thing with the W. So go ahead and find the modulus of the W. Are we cool so far? It's not overwhelming, we're good. So it looks awful all in writing, but it's not terrible. So -5 squared plus -3 squared. So 25 plus 9. Is that 44?
36.
so close. 34. 95 is 14, okay. All right, are we cool so far? Okay, in the same breath, I would like us to now find the arg of u, and then we're gonna find the arg of w. Practice our skills, okay? See if we can remember how to do it. So the first guy is 9 and 12. What quadrant am I in?
First.
Okay, so I'm truly looking in the first quadrant, the value is gonna be, it is what it is. Does that make sense, what I'm saying? So if I was to do kind of a little quick sketch over 9, up 12, there we have it, yep. So we have our little line, and it's 9 plus 12i. So do you guys remember how to go about finding it? What's the little formula that gets me there? Tan of theta equals y over x, right? Mm-hmm. Okay, once you go ahead and find that for me, see how you do on it, what you get. 0.927. Are we cool? Okay, and I'd like you to go ahead and find the argument for W as well. Okay, so let's kind of remind ourselves from yesterday. We're gonna go backwards 5, down 3, it's over here, right? Okay. Does anybody remember how to go about doing it? What's the little thing that kind of gets us there?
Negative 5 plus alpha.
Yes, negative 5 plus alpha. So the way you do it is you find over 5 up 3, find that guy, and then do negative 5 plus your answer. Is everybody okay with that? All right, so go ahead and try that. I guess we should do alpha. Any luck with this? Anybody want to tell me what they're getting for their answer? Nobody dares? I know. Not doing it today. Ben is just looking at me like, mm-mm. Do you not have a calculator that'll do it for us today?
Got
Or-
negative 2.6.
Yeah. Yeah, we're good. Is everybody cool?
How many sig figs last week?
They like 3 sig figs,
Okay.
is what they like.
I got like negative 2.60.
Yes,
Yeah.
that would be 4, right?
Okay.
So, yeah, negative.
Will they say how much they want? Or just go to?
We're just gonna go 3 sig figs, yeah, unless they otherwise tell us. I'm not gonna say you're gonna get it wrong if you put negative 0.2601, unless they specify 3 sig figs, but for the most part, that's what they're kind of looking for. All right, are we good so far? So, using what we know now, everybody agree this is a modulus for u, this is the modulus for that, and then that's the argument for u and that's the argument for w. How do I go about finding the modulus of u, w? So the modulus of u times w is each of the individual moduli multiplied together. Yeah. So what do I get? In this case, it's going to be 15 times the square root of 34. How do we feel about that? It's really not bad. Okay, what would the argument of u w be? Okay, so what does it tell me to do the argument if I'm multiplying? It tells me to take the argument of the first guy and do what with the second guy? Add it. Mhm. So what was the argument of the first guy? 0.927, and then plus negative 0.260. And what do you get when you do those together? All right, how do we feel about that so far? Are we cool? Yeah? Okay. Then the next thing it wants us to do is it wants us to do the division one, okay? So we're going to try to find guess if I move over here, I have more room. Right, so we're going to do the division of U and W, so I want to find the modulus of that. So how does it tell me to do the division of them? Literally divide the two guys, right? So what do we get? We get the U was 15 over the square root of 34, and I'm gonna tell you, for the most part, I would suggest not leaving square roots in your denominator, so go ahead and clean it up a little bit. All right, are we good so far? And then let's go ahead and find the, I think we're cool there. And then let's go ahead and find the argument of it. And what does it tell me that I have to do with the arguments? Subtract them. That answer there. You get 3 point, yeah. Now, there's a problem, because remember, when we're doing this, we're trying to figure out how far it is from the x-axis, whether it's above and below, and so your answer can't be bigger than pi, because that brings you, from here, it brings you below, and then from here, it would bring you above. So if I went from here to 3.5, it would be down here. Does that make sense? So that's 3.14 and then some more. Does that make sense? So we're really trying to find the other side of that that's equivalent to it. However, we're not going in the negative direction. So we actually are trying to find where that is in the positive. So the way you do that is you have to figure out how far it is from here to over there. And it's what they call the principal argument. It's the other side of it. So the way that they do it, and let me show you, and this doesn't happen every time. They're finding their new theta, myself some space here. They've found their new theta to be 2 pi minus that 3.528. So they're taking the whole, do you know what 2 pi is? It's all the way around, right? So they're taking 2 pi minus this, that's gonna give me this, except for it's the other direction. So we're gonna negate it, so we can figure out that spot. Because, I'll do it in a different color. From here to here, and then from here to here, meet in the same spot. So we're trying to find the place that meets it over on that other side. So take 2 pi minus that whole red, that's going to give you this, but we're gonna go in that backwards direction to get to it.
Is this just what you do every time?
To make sure if it's bigger than 3.14, you gotta meet it the other way. Of 3.528.
2.755.
And it's negative because it's going that direction. So you're doing the negative aspect of it. So it's negative what? Negative 2.75. So let's say your answer initially was this. Let's say it's negative 3.528. Let's say that's the answer you got, right? What am I looking for to get the actual answer that would be smaller than pi? So I'm looking for us to go this way to meet it. Does that make sense? So how would I get that answer? If this guy went from here to here in the negative direction, so I'm looking for the positive aspect of it. So what am I gonna do in order to find that answer? What would it be? The whole round would be 2 pi, and what would I be getting rid of out of that? I'd be getting rid of that 3.528, right? And I would get a whole answer. So I would have 2 pi, and then I'm gonna subtract the 3.528. So go ahead and do that for me. 2 pi minus 3.528, what do I get?
Two point seven five five.
Say it again to me.
2.75.
Makes good sense, right?
Yeah.
So does it make sense that this is positive 2.75? The whole thing would be 3.14. To get to that same line, right, would be at positive 2.75. Going in this direction is positive, going this way is negative. So you just have to meet it. Does that make sense or not? Okay, so the only time you have to do this is when? Is when your answer is greater than 3.14. Whatever directional you're going. Okay? All right, what do you think about finding an argument of 2 things multiplied or divided? Yeah, okay. Yay. So that was that. We've already done square roots.
That's it.
All right. So now, we're gonna do one more thing. It's called loci. It's exciting. And then I'm done. And then we're just gonna work on the problems. And what I did, I printed out actually for my own, like, in-hand purpose,